An engine that runs on hydrogen, delivering power for hundreds of miles, with nothing but water as its emission. It sure sounds incredible, like something straight out of a futuristic movie. But what's even more interesting is the fact that Toyota turned this fantasy into reality with its new hydrogen engine. With the advent of this innovation, the Toyota hydrogen engine could make a new era for sustainable driving, pushing the boundaries of what engines can achieve. In this video, we'll break down how this remarkable engine works, how it's different from traditional and electric engines, and why it could redefine sustainable performance in the automotive world. Let's dissect this futuristic tech that's challenging everything we thought we knew about engines. As the name implies, a hydrogen engine is an engine powered by hydrogen gas. Hydrogen itself has numerous uses: power generation, energy storage, and even residential heating. But when it comes to cars, it's the driving force behind hydrogen electric vehicles, with the fuel cell as the core component. But how does hydrogen actually power an engine? You see, a hydrogen engine consists of a hydrogen tank that stores highly pressurized hydrogen gas. The gas, H2, is fed into the anode, and molecular oxygen, O2, from the environment enters the cathode of the fuel cell. These two gases then undergo an electrochemical reaction inside the fuel cell, in turn producing energy. This energy is then used to power the hydrogen car's electric motor, hence keeping the car in motion. However, aside from the motor, the energy produced is also used to power other electronic components of the car. But what makes this process cool is the fact that the only byproduct, or waste, if you may, that is actually produced from this whole process is water vapor, and not the toxic black fumes we see coming out of the exhaust pipes of May cars in the streets. The Toyota Mirai engine, the new Toyota hydrogen engine, powers the Toyota Mirai car. Being similar to electric vehicles, hydrogen-powered vehicles, like the Toyota Mirai, offer all the benefits of driving an electric vehicle, such as the lack of engine noise, enjoyable driving experience, and zero emissions. This is all thanks to the engine. The new Toyota hydrogen engine packs a lot of cool features that makes it stand out. These include a Toyota FC stack, FC boost converter, and high-pressure hydrogen tanks. Toyota FC stack achieves a maximum output of 114 kilowatts in addition to its electric motor, which is 136 kilowatts, totaling a combined power of 250 kilowatts. This is much higher than the power output of EVs, which is averagely 100 kilowatts. The higher power output of the Toyota Mirai indicates improved performance in speed, acceleration, and much more. FC Boost Converter. A new compact, high-efficiency, high-capacity converter has been developed to boost power generated in the Toyota FC stack to 650 volts. With higher voltage, the electric motor can be designed to be smaller, while still delivering the same or improved performance. This reduction in size can lead to weight savings and better vehicle dynamics, leading to a smaller, higher performance, more efficient Toyota fuel cell system, thereby reducing manufacturing costs and potential prices for consumers. High-pressure hydrogen tanks. The Mirai's tank is constructed with a 3-layer structure that includes carbon fiber reinforced plastic and other materials. This design enhances the strength and durability of the tanks while minimizing weight, and can store hydrogen at a very high pressure of 70 megapascals. This high-pressure storage allows for more hydrogen to be stored in a smaller volume, which is very necessary for maximizing the range of hydrogen fuel cell vehicles. Asides the reduced toxic emissions, the Toyota hydrogen engines comes with a few other benefits for the Toyota Mirai. For instance, due to its hydrogen-powered battery, the Toyota Mirai takes a much shorter time for refueling when compared to electric vehicles of the same size. It takes approximately 5 minutes to refuel, while an electric vehicle takes anywhere from 20 minutes to several hours. Also, hydrogen fuel cells are not significantly impacted by the outside temperature and do not deteriorate in cold weather, unlike EVs. Furthermore, hydrogen has a markedly higher energy density than lithium batteries, with specific energy of up to 40,000 watt-hours/kg. compared to EVs with 250 watt-hours/kg. As a result, hydrogen engines generally offer longer driving range of 600 miles, which is longer than electric vehicles, which have shorter range of 400 miles. The components of the Toyota Mirai engine. Fuel filler. A fuel filler is the point of entry for fuel into a vehicle and is made up of several parts, including the fuel filler neck, fuel filler cap, and fuel filler pipe. It is made up of a fuel filler neck, a cap, and a pipe. Together, these three parts allow the easy delivery of hydrogen into the Toyota Mirai and prevent its leakage. The pumped hydrogen is stored in vessels known as fuel tanks. Electric traction motor, FCEV. An electric traction motor is an electric motor that converts electrical energy into mechanical energy to propel a vehicle. Using power from the fuel cell and the traction battery pack, this motor drives the vehicle's wheels. DC-DC converter. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Fuel cell stack. The fuel cell stack is an assembly of individual membrane electrodes that use hydrogen and oxygen to produce electricity. The unique design of this piece exponentially increases the amount of voltage output that can be provided by the system. Battery pack. The battery pack stores energy from regenerative braking and provides extra power to the electric motor. It also captures excess power from the fuel cell stack when the vehicle is driving with low energy. An auxiliary battery. The Toyota Mirai comes with a low-voltage auxiliary battery. Unlike hydrogen fuel, this battery serves to provide the electricity needed to start the car before the traction battery is engaged. It also powers vehicle accessories. Power Electronics Controller, FCEV. This unit manages the flow of electrical energy delivered by the fuel cell and the traction battery, controlling the speed of the electric traction motor and the torque it produces. Thermal system, cooling, FCEV. This system maintains a proper operating temperature range of the fuel cell, electric motor, power electronics, and other components. Transmission, electric. The transmission transfers mechanical power from the electric traction motor to drive the wheels. The Mirai delivers everything expected from a next-generation car, an immediately recognizable design, driving exhilaration stemming from superior handling stability achieved by a low center of gravity, and quiet but powerful acceleration provided by the electric motor. The Mirai features the TFCS, a fusion of fuel cell technology with hybrid technology. Challenges. Despite the myriad of benefits it seems to possess, this is not to say that Toyota's hydrogen engine doesn't have its fair share of shortcomings. Most of these shortcomings come from the use of hydrogen itself as a fuel source. Unfortunately, these challenges can affect the widespread adoption of the Mirai and hydrogen fuel cell technology as a whole. So let's take a quick look at them. Hydrogen extraction. For one, although hydrogen is indeed the most abundant element in the universe, hydrogen does not exist on its own, so it needs to be extracted from water via electrolysis or separated from carbon fossil fuels. Both of these processes require a significant amount of energy to achieve. Scarcity of hydrogen fuel. Another reason you don't see hydrogen engines popping up everywhere is the fact that there is a severe lack of infrastructure for hydrogen cars, with refueling stations few and far between. This scarcity makes it difficult for consumers to refuel their vehicles, limiting the practicality and convenience of owning a hydrogen fuel car. For context, the fuel cell in the Toyota Mirai is rated at 120 GP, while an average Tesla can be up to 400 GP. This is indicative of the acceleration, as EVs have higher acceleration than hydrogen fuel cells. High production costs. The technology and materials used in hydrogen fuel cells are expensive, leading to higher vehicle prices. And there you have it, guys. Toyota's hydrogen engine is a real game changer. It uses hydrogen, one of the most common elements around, to create power without any pollution. Just water vapor. No CO2, no harmful emissions. plus the convenience of quick refueling, it's all here. Safe to say that this innovation is bound to change the world. And with more hydrogen stations popping up, we could be looking at a new era of eco-friendly driving. Thanks for sticking around, and make sure to catch more updates on the latest in car tech.